Hey everyone, welcome back to the channel. Today we are going to solve a classic problem from the CSES problem set called the weird algorithm, also known as Collatz Conjecture. This is an introductory problem that looks simple at first but is a great exercise in simulation and control flow. We will walk through the problem, the approach, and then I will show you how to implement it efficiently. Let's jump into it. Here is how the algorithm works. You are given a positive integer n. If n is even, divide it by 2. If n is odd, multiply it with 3 and add 1. You have to do it till n becomes 1. For example, if n is equals to 3, then 3 is odd, so 3 into 3 plus 1, which will become 10. 10 is even, so 10 by 2, 5. 5 is odd, so 3 into 5 plus 1 is equals to 16. 16 is even, so 16 by 2, 8. 8 is even, 8 by 2, 4. 4 is even, 4 by 2, 2. 2 is even, 2 by 2, 1. Since we encountered 1, we can stop here. Your task is to simulate this process for any given integer n and print the sequence as it evolves. So, for this 3, the sequence will be 3, 10, 5, 16, 8, 4, 2, 1. The constraints are pretty simple. The n will be from 1 to 10 power 6. So our approach should be efficient enough to handle even the largest values of n within the given time and memory limits. Now let's break down the approach to solving this problem. First, we'll take integer n as input. We'll run a loop until n becomes 1. So we'll take a while loop. While n not equals to 1. If n is even, so n divided by 2. If n is odd, n is equals to 3 into n plus 1. Each time we update n, we also print current value, cout n. Note that we don't need to store the sequence anywhere. The problem simply asks us to print each value as we compute it. This will save memory and allow us to efficiently handle the sequence generation. For this, we have to take the input n in long, not int. Because if it is 10 power 6 minus 1 and maybe it may goes to largest value. So let's be safe and take n data type as long. So int main long n, take input n while n not equals to 1, cout n. So we are printing the sequence here. If n mod 2 is equals to 0, if it is even, n by is equals to 2, else n is equals to 3 into n plus 1. So after finishing the while loop, we have to print 1 because we are not printing it before. After that, return. Let's also quickly see some edge cases. Minimum input, which is n is equals to 1. In this case, the sequence immediately ends since n is already 1. Large value of n. Since the problem is allows up to 10 power 6, you should keep in mind that the sequence might get large, but with efficient printing and without storing results, this will work within the time and memory limits. Although the sequence can grow quickly, the operations in the loop are efficient. The time complexity of the algorithm by the number of steps it takes n reach to n to reach 1, which is generally around order of log n, not n, depending how often division by 2 occurs. Since we only need to print each value once, this keeps the solution both time efficient and space efficient. Since we are not using any space for storing, the space complexity will be order of 1. And that's it. You have seen how to solve the weird algorithm from CSES problem set. It is a simple simulation problem that helps you get familiar with loops, conditions, and optimizing I/O operations for large inputs. I hope you found this video helpful. If you like this video, don't forget to hit the like button and subscribe to the channel for more competitive programming solutions. Feel free to leave any questions or comments down below, and I will be happy to help. Happy coding!